Ashija, Assistant Professor, Department of Computer Science and Engineering, Savitha School of Engineering. In this video, we are going to see about computing a binomial coefficient. So first we can see what is binomial coefficient. A binomial coefficient is an algebraic expression that contains the terms a, b plus b likewise. The binomial coefficient of n and k is written as c of n comma k or nc or nr. The general formula for binomial coefficient is NCR is equal to n factorial divided by r factorial into n minus r factorial. Example, 5c3, we know the factorial 5 is 5 into 4 into 3 into 2 into 1. Likewise, we will write for 3 factorial and 5 minus 3 factorial. After strike out in the common values, we will get the value 10. So 5c3 is 10. Now, by using dynamic programming concept, we are going to compute the binomial coefficient. So to find the binomial coefficient of 5c3 using dynamic programming concept. So here n is taken as 5 and r is taken as 3. So this is the formula for computing the binomial coefficient using dynamic programming concept. C of I comma j is equal to C of I minus 1 comma j plus C of I minus 1 comma j minus 1. So there is a shortcut method called Pascal triangle for computing the binomial coefficient using dynamic programming concept. So here we will construct a table in which we will take the entries of r and n. So r, we know in the problem it is given as 3. So we have to start with 0, 0, 1, 2, 3. And in the example for n we have taken as 5, 5c3. So for 5 we will fill 1, 2, 3, 4, 5, and here also it should, n also should start with 0. N and r should start with 0. Then first we can see how to fill this x mark. So first you have to check the value of I. So this is taken as I and this is taken as the j value. So I is equal to 0 to n, 0 to n, and j is equal to 0 to minimum of I comma r, minimum of I comma r. So I is equal to 0 to 5, j is equal to 0 to minimum of I comma r. J value is greater than I. Here in the first the value 0 and 0, this is equal. So we will leave this value, then 0, 1. Here j value is greater than I. So we will mark an x entry here. So after x we should not perform any computation. We have to stop the computation here. Likewise in the next step 1, 0, then 1, 1. In this place the value of j is greater than I. So we will mark an x in this region and we will stop the computation in this cell. Likewise in the next row 2 and 0, it is smaller than I, so we will leave it. 2 and 1, it is smaller than 2, so we will leave it. Then 2 and 2, that is equal, so we will leave it. 2 and 3, here 3 is greater than the value of 5, so we will mark an value x here and we will stop the computation here. So this is the first step. So have you understood how to mark x in the table? And then in the 0th column we have to mark all the entry as 1. In the 0th column we have to mark all the entries as 1. Clear? Then we have to write the diagonal element of this x marking as 1. Below this x you have to write 1, below this x you have to write 1, and below this x we have to write 1. So below this diagonal x we have to write 1 in diagonal format. After that we have to compute the remaining values. We have to compute these values. So let us see how to compute these values. So to compute these values, first we have to take the diagonal value 1 and the value above it. So 1 plus 1 is 2. We will take the diagonal value plus the value above the cell. So 1 plus 1 is 2. Likewise here we will take this diagonal value as 1 and the value above this cell is 2. So 1 plus 2 is 3. Likewise we have to compute all the remaining values. So after computing these values in the shortcut method, we have to check by using our formula method. Then now we are going to check whether the value in the cell C of 1, 1 is correct or not. So C of I, j is taken as 1, 1. So the formula is I, C of I minus 1, j plus C of I minus 1, j minus 1. Substitute the values in this formula. So we will get 1. So C of 1, C of 1, 1 is 1. Likewise C of 2, 1 is 2. So this is the method of calculation using the formula, and this is the shortcut method.